Hi, it's great to be here. I'm Martijn Walraven. I work at Meteor, and sort of over the last 6 months, we at Meteor have become increasingly excited about GraphQL, to the extent that we actually started a new project, the Apollo project, and sort of the one-sentence summary of what Apollo is about is that it's about building tools to improve the GraphQL developer experience. So we're building on GraphQL. We're really grateful for what Facebook has given the world. We think GraphQL is an amazing technology. But there's a lot that can be done with it, and especially once you start using it outside of Facebook, when you think about connecting it to different backends, different front-end technologies, different languages even, there's a lot that still needs to be done. So for us, Apollo over the last couple of months has been sort of an amazing experience. We've tried out a lot of things, we've learned a lot, and we've open sourced a couple of tools. And there's one sort of underlying philosophy for those tools, and that's that we're really trying hard to focus on modularity, transparency, and simplicity. Like, we really want to build tools that do one thing well, that are easy to understand, easy to debug, that offer sort of really an API surface that helps us sort of compose these tools into new environments. And one of these tools, something you may have heard of, is Apollo Client. And Apollo Client is an alternative to Relay, you might say. So it's a GraphQL client that builds on Redux. And if you sort of look at the landscape of GraphQL today, it's interesting that GraphQL is still mainly associated with JavaScript. That makes sense. It was introduced as part of Relay, a JavaScript client. It was also sort of seen as coupled to React. Most of the talks on GraphQL are still at sort of React conferences. And we've seen other implementations of GraphQL in different languages, but mostly on the server. So we have Python implementations, Scala implementations, like many different languages. But on the client, it's still mainly JavaScript. And what's interesting about that is that mobile is actually an important sort of use case for GraphQL. And if you look at where GraphQL came from, this is the Facebook iOS app in 2012. And GraphQL was actually developed as part of this effort. This was an effort to rewrite the main Facebook app, from an HTML5-based app to a fully native iOS app. And it was a huge success. But without knowing it, sort of hundreds of millions of people have actually used, for the past 4 years, an app powered by GraphQL. And I think that's amazing. If there were any questions about sort of whether GraphQL is production ready, I think we've established that by now. It's outside of Facebook. There's still no easy way of using GraphQL in native mobile environments. So over the past few weeks, I mean, this is really early, I've sort of tried my best to explore the design space of what a native client could look like. But first, let's talk a bit about why GraphQL is so suitable for mobile clients. And the main issue here for mobile clients is that there's high network latency. Like mobile clients generally connect to networks that have fairly high latency, even up to several seconds. So what you really want to avoid is a situation where you have to do sort of repeated round trips to get the data for a single view. And this is something sort of most developers have encountered when they work with REST. Like you may start out with a sort of neatly designed REST structure, separate endpoints for every object, but then sort of the real world kicks in and you need data together. You don't want repeated round trips, you just want the data you need for that specific view. So you create new endpoints that give you exactly the data you need. But then it's not just one client, it's multiple clients for different platforms with slightly different requirements, slightly different data requirements. So before you know it, you're actually sending data to clients that don't actually need it. You're overfetching data. And the situation becomes worse when you consider sort of different versions of these clients that each have slightly different data requirements. So for major versions, you may actually have to create new endpoints that you then have to maintain, that duplicate code. So in general, this whole model of clients connecting to separate endpoints and servers deciding what to send isn't scalable. And GraphQL is just an amazing solution to this. Clearly defined responsibilities. The server defines what data is available to clients in the form of a GraphQL schema. Clients write queries that specify the exact requirements, the exact data needs that they have. So it's a great way of decoupling clients and services. So if you were talking to a native developer, I think this is something most people will understand. This is something every mobile developer has to deal with. And then you could even show them GraphQL, which is sort of an amazing user experience. It really shows you the power of GraphQL, of having types available, of doing arbitrary queries. But after a while, a native developer might ask you, how? Like, how do I actually connect my native mobile app to a GraphQL server? And at that point, you might have told him about Facebook, about the Facebook apps. But the technology in use at Facebook is sort of tightly coupled to the Facebook infrastructure. It's not something that's open source at this point. You might point him at the GraphQL specification, which is, I'm really glad we have a well-written spec, and it's worth reading if you're interested in GraphQL, but it's also overwhelming. It's not something that'll help convince people that GraphQL is simple. So what I'd like to do is look at GraphQL clients in sort of different stages, demystify what it is really sophisticated GraphQL clients like Relay or Apollo client are capable of. And this is sort of an example app that we've been working on at Apollo. It's a product hunt for GitHub repositories. Basically, it allows you to sort of post repositories. It allows people to vote on them. We're working on comments. And what's interesting about this GraphQL schema, about the GraphQL schema that underlies this, is that it contains data both from an application-specific database for the entries and the votes, but also information that comes directly from the GitHub API, things like the number of stars or issues. So if you wanted to query the information in this schema in a native app, what would you do? Well, the basic conceptual model of GraphQL is request-response. You make a request in the form of a GraphQL query, and you get a response in the form of JSON. although it's not strictly part of the specification, the network transport that's most often used is HTTP, and there's a simple way of making an HTTP post request with the GraphQL query and just getting JSON back. And this is not dissimilar to what you would do with a REST endpoint. It's something that native developers could just plug into their sort of existing app. So this might actually be a good way in. It gives you a lot of the benefits of GraphQL without actually doing much sort of GraphQL-specific work on the client. But you're not fully utilizing GraphQL. And sort of the first thing you might want to think about is typing. If you're returning raw JSON to a native client, written using a typed language like Swift or Java, it's a pain to work with. Like in JavaScript, JSON is a format we're all happy with because it's really easy to work with plain JavaScript objects. In typed languages, you have to cast, you have to make sure you don't return nulls, and it's in general, sort of well-designed mobile apps try to avoid this by inserting a sort of typed layer, a layer that parses the JSON responses into typed objects. But this is either completely custom written or it's something that's generated from separate type schemas. And in GraphQL, we actually have a really nice type system built in. So we definitely want to take advantage of that. And I think this is where code generation comes in. And I wasn't sure whether code generation was the right solution. I think at this point, it makes a lot of sense for the languages we're considering. And what's also interesting is that I've learned a lot from talking to the GraphQL team over the last couple of days. And code generation is also used in the iOS and Android apps. So it seems to be something that's working for them, even at that scale. So the idea is that based on GraphQL type information, you generate value types. And I would advise everyone to generate immutable value types based on the rest of your architecture. But I think single direction data flow is a well-established pattern by now that just makes everyone's life much easier. So your first idea might be to generate these types based on the GraphQL schema. And this would work, but there are some serious downsides to it. The first downside is that you're generating fields in your classes for sort of every field in your GraphQL schema. And schemas tend to grow. They tend to contain, like at Facebook, I think some types may contain sort of hundreds of fields. And you definitely don't want all that information in your data types. Also, when you're querying, you're specifying your exact data needs. And you want to make sure that on in your UI code, you only have access to the data that you actually asked for, that you know is there. So a better approach is to generate query-specific types. So for this query, for instance, we're getting access to a repository with a full name field. So we're generating a repository with just a full name field and a stargazers count. And then we have a user, an owner in this case, and we only give access to 2 fields. And the easiest way of doing this is to use nested types. And I have a small demo of this in Swift that I think is interesting. Let's see if I can. So what you see here is a Swift playground and a query model that specifies specific types. So this would be generated. It contains nested structs and the query string. Here's a separate query with separate information. And what this gives you is, here for instance, we have the full name, but we have other fields available. So for instance, the stargazers count is something we could use here. And that'll auto-update. So for this repository, we have access to the full name and the stargazers count, exactly the fields we specified in our query. For this query, we have access to the repository description, but not, for instance, the stargazers count or any of the other fields. And the way this works is with some sort of type magic, the use of generics in Swift. You could do something similar in Java. And I think this is a really promising direction because it gives you strong typing based on the actual queries you're performing. So there are a couple of things you might improve about this. One is that these types are really query specific, and they're even specific to sort of the part of the query they're in. So if you look at this example, we have an owner and a posted by that both refer to a user, but they're completely separate types in the generated data structures. So you couldn't, for instance, write a UI component at this point that would display the user, both the owner and the posted by. The way to solve this is by using fragments, and then using these fragments to generate something like interfaces or protocols. And this will give you a really easy way of getting both type safety and the ability to still have query-specific data classes. So another important feature of GraphQL clients is that they help you keep your data consistent. So an example of that would be querying for all the repositories in a feed, getting, for instance, among other repositories, the Facebook GraphQL repository with a score of 3, using that, for instance, to show something in your UI. If you then do a second query for just that repository, and in the meantime, a lot more people have actually upvoted this repository, you get a different value, but the original UI component will not automatically update. So what you want as a GraphQL client is a single source of truth. You want to make sure that objects, like repositories in this case, have a single representation in your system. And a normalized data cache is the easiest way to do this. So you basically break up the tree of your query into separate objects. So you normalize the results. You store those separately using something like an object ID or another way of uniquely identifying objects. And you can then use that single normalized cache to distribute data to your different UI components. So on your client, you use the queries bound to UI components to query the cache. And that gives you both sort of the results of queries you've done yourself, but also updated information that might come in from other queries or even from other update mechanisms. There are a bunch of other interesting things you could do with this. So for instance, it allows you to minimize the queries that you actually send to the server. You can do diffing of queries, and that allows you to reuse information that's already in the cache and only query for information that's not there. There are a bunch of sort of other topics that I'd like to explore over the next couple of weeks and months. These are definitely things that I think are interesting for mobile developers. Of course, mutations. Mutations are similar to queries, so they return data that can be stored in the cache. But they also allow you, and this is important for mobile apps, to optimistically update your UI. And for mobile apps, because there's high latency, when you do a mutation, you don't really want to wait up to a couple of seconds to update your UI with the result of that action. So you can specify as part of a mutation the updates that you think will be performed, the result that you expect from the server. You can store that in sort of a temporary action queue. And when the real response from the server comes in, you revert that change and you make the real change you receive from the server. Another interesting topic is offline support. This is, of course, something that, especially for mobile apps, is really beneficial. Depending on how you structure your store, there may be fairly simple ways of defining sort of serialized representations of your normalized data and keep those in a persistent storage location. There's pagination, fragment composition, things we know from sort of sophisticated JavaScript clients like Relay, and that definitely have their place on mobile as well. I think sort of the most important message right now is that this is a community-driven project. Apollo is a community-driven project. So we really want to hear from people who either have existing native apps that they'd like to use with GraphQL or have projects they might be starting up. And together, we hope we can sort of bring the native client space for GraphQL further. All right, well, thank you. There are a couple of places you can go to if you want to sort of keep track of what we're working on and engage with the project. Our Medium blog is a really nice source of sort of up-to-date content. We tend to blog about things that we've been working on or thinking about. And in general, please get involved either by contributing to one of our projects on GitHub, by contacting us on Twitter, and let's together help improve the native client space for GraphQL.